All right, let's take a look at learning goal 44, which says I'll be able to use proportions to solve problems involving scale. Okay, and we'll go up here and fill in your learning goal of 44. Okay, going down to the maps and scale. Here we go. All right, so what I want you to see is the repetition of ratios and proportions. It's things that we've already been doing. Okay, so it's not that much different. The one twist I want you to be aware of though is that ratios for scale, they're all written the same way. They have that drawing or model, and that's going to be the first number, and then the actual is going to be the second number, or your denominator. Okay, so something a little bit different with this that you just need to be aware of when you're looking at scale models of things. So let's go ahead and work on simplifying a scale. So if you know something for every 2.5 inches on a drawing, or a like model car is actually 27.5 feet. We want to know what a simplified scale is, and that means 1 inch in the numerator and whatever the actual is in the denominator. Okay, and so I'm going to set up this proportion and write 2.5 inches over the 27.5 feet. And we're going to set it equivalent to what we want. So we want 1 inch in the top, and x feet is going to be our unknown variable. So of course we could cross multiply or use means and extremes to solve this. Or we can just look and see, can you make one? And these are typically nice and easy because we know that if we take a number and we divide by itself, any number divided by itself equals 1. And so I already know that I can just divide by 2.5 over 2.5 and create an equivalent fraction rather than doing means and extremes. So the 2.5 divided by the 2.5 is going to get me my 1, and the 27.5 divided by 2.5 is going to get me 11. Okay, and so without doing means and extremes, I have a quick way to get my answer. Okay, and so the simplified scale is for every 1 inch, we have an actual of 11 feet. And that's the actual order. And I'd like you to write this. So 1 inch of a drawing is 11 feet actual. And that's the order for scale that we're doing. So let's go ahead and look at maps. Okay, so for every 1 inch of a map is actually 3/4 of the mile. Okay, so 1/3 inch of a map is actually 3/4 of a mile. Remember, to simplify a scale, we want to know what is it for 1 inch drawing on a map, or distance on a map. And so this is our x is miles. Again, you could cross multiply or do means and extremes if you want. I just find it easier to understand that 1/3 divided by 1/3 equals 1. So I already know there we're just dividing by 1/3 over 1/3. Okay, 1/3 divided by 1/3 equals 1 inch. So now all I have to do is 3/4 divided by 1/3 to get my x. I know that I don't divide fractions, so I'm actually doing 3/4 times the reciprocal, and we end up with 9/4 miles. Okay, and so I wouldn't really leave it at 9/4 miles just because that's not how we talk. So I would say 1 mile in my drawing or my map distance is the same as, let's see, 2 wholes and 1/4, because 2 times 4 is 8 plus the 1 miles. And sorry, I messed up my miles here. That's 1 inch in my map drawing is 2 1/4 miles. And so here's my simplified scale. This is my drawing. And this is my actual. So it's in the format of scale. Okay, a ratio of scale. All right, so let's go ahead and use that same understanding to find some actual measurements based on a blueprint. Okay, so my blueprint over here, you can see they're saying for every inch of my drawing here, okay? Centimeter. For 1 centimeter, this is actually 2.5 meters in real life, okay? And so our scale, we're going to do the small thing first, the drawing or the model. So our scale is 1 centimeter is 2.5 meters in real life, okay? So we want to use this scale to go ahead and find the actual height of the chimney, okay? So letting us know that the chimney is 4 centimeters tall in the drawing, okay? So let's go ahead and put our 4 centimeters on top, okay, to figure out how many meters the actual height of the chimney is. So again, we could cross multiply, okay, which wouldn't take very long. I could end up with 1x equals the 4 times the 2.5 and then do my dividing on both sides. Or I can just see, okay, I can look at this and go, well, this times what will get me 4, okay, and create an equivalent fraction. And so that's a nice easy one. I know that I would just multiply by 4 over 4 to create that equivalent fraction. 1 times 4 is 4. 2.5 times 4 is 10. And so I know my actual height is 10 meters. And there we go with my answer. Okay, let's go ahead and look at this architectural drawing problem. So we have the length of a room in the drawing is 3/4 of an inch. Okay, so this is the length. And then the actual length is 3 1/3 feet. And they want to know what the scale is. Okay, so this is dealing with lengths. Okay, so our drawing is 3/4 of an inch. Okay, and our actual that goes on the bottom is 13 1/3. Okay, so we know that we don't want to be working with the mixed numbers, so we end up with 40/3 in feet. Okay, so this is my given scale. They said for every 3/4 inches, we have an actual 40/3 feet. Okay, so now I'm going to bring that over to find what the 1 scaled inch is, meaning for every inch, how many feet do I have? So we're going to do our 3/4 inches over 40/3 feet. Okay, and we want to know what the 1 inch is. Okay, and so x is going to be our actual feet. So again, we can cross multiply if you want and do means and extremes method, or you can just look at your 3/4 and go, okay, well, how do I create one whole? And so 3/4 divided by 3/4 is going to make one whole. So I can do 3/4 divided by 3/4 over 3/4, okay, and create an equivalent fraction. The top all equals the one whole. I just have to do the bottom. Remember, we don't divide by a fraction, so I'm actually going to do 40/3 times the reciprocal, which would be 40 over 3. And so I'm going to look and see if I can cross simplify. I cannot, so I'm just going to multiply straight across. So we end up with 40 times 4, which is 160. And then 3 times 3 is 9. So we have 160 for this. And I'm going to go ahead and I want to change that into a mixed number just because we wouldn't normally talk like that. So for every 1 inch of a drawing, let's see, 160 divided by 9. Okay, we have 17 and leftovers. So we have 17. 17 times 9 is 153. So 17 and 7/9 feet. Okay, and so this is our 1 inch scaled ratio. So for every 1 inch is an actual 17 and 7/9 feet. So I can write the scale as a ratio. That fraction already is a ratio, or I can write 1 inch to 17 and 7/9 feet. Okay, you can write it like that as well. Okay, all right. This last one, let's go ahead and use means and extremes to solve, just because we haven't done that. And I want you to be able to see that example, even though you can see it's pretty easy to just create equivalent fractions with these. You want to make a scale model of a sailboat. It's 51 feet long and 15 feet wide. You plan to make a sailboat that's 17 inches long. Okay, how wide should the model be? So let's set up the ratio that we know. Okay, so we have our 51 feet long to 15 feet wide. So the things that we're matching up are the length and the width. So let's set it equivalent, because we know it's an equivalent ratio. So we have 17 inches long. So I need to make sure the length is on top. That's why these labels are so important. And then I don't know how many feet wide my scale model should be. So for this one, again, you can see we could figure out what to do from 51 to get 17 by just dividing 51 divided by 17. So it tells us that that scale factor is divide by 3/3. But I am going to go ahead and just show you the means extremes just because we haven't done it, like I said, in these notes. So let's go ahead and do that cross multiplying. I always do the x variable multiplication first. So we have 51x equals 17 times 15 is 255. And then we just know that we divide both sides by 51 to get x isolated by itself. Divide by 51, and we get 5, which is what you would have got if you did the 15 divided by 3 as well. Okay, so we have 5 feet wide is how wide the model should be. Okay, and so here's the answer to my question. All right, that is it for maps and scale drawings.